Hi, now we going to talk about strain. Strain is a quantity that describe the deformation that occur within a body. It tells us how much a material stretch or compress under load. Common type of strain is normal strain, which is epsilon. It is defined as the change in length divided by the original line. This means that is a material elongated under tension or shortened under compression. We can quantify its strain using the simple ratio. Describe a process for computing strain transformation, principal strain, and maximum in-plane shear strain based on given input strain value and angle. First step, we must go to start, which mean the process will begin. Second, input angle and strain value. The user must input angle 6 input, which is theta A, theta B, theta C, epsilon A, epsilon B, and epsilon C. Third, solve the system of equation. The system of equation is solved simultaneously to determine strain component epsilon x, epsilon y, and gamma xy. The simultaneous equation is given here. We'll insert in this stage. Third, input transform angle. The user must input the transform angle, and next calculate transform strain. Epsilon x prime, epsilon y prime, gamma x prime y prime using formula 1. The formula 1 is given here and we'll insert in this stage. Next part, calculate principal strain and orientation. The principal strain epsilon 1 and epsilon 2 and their orientation, which is theta, are computed using formula 2. Formula 2 also has been given here and then insert in this stage. Next, calculate maximum in plane. Calculate maximum in plane shear strain and orientation using formula 3. The maximum in plane shear strain, which is gamma max in plane, and its orientation, the theta s, and corresponding normal strain are determined using formula 3. This formula insert in this stage. And the 8th stage, decision process. If epsilon x is bigger than 0 and epsilon y is bigger than 0, it will compute yes, and the result will come out gamma maximum absolute equal to epsilon x. And last, will display absolute maximum and shear strain, normal and shear strain, transverse strain, principal strain and orientation, maximum in plane shear strain and orientation, and then we'll end. If no, the epsilon x is bigger or lesser and epsilon y is lesser than 0, it will say no. It will go to the next stage, which is if epsilon x is less than 0 and epsilon y is less than 0, they have two options, yes and no. If right, it will go to yes and will come out the result gamma maximum absolute equal to epsilon y, and then go to the next stage, which is same as the first option, which is must display absolute maximum shear strain, normal strain, transform strain, principal strain and orientation, maximum in plane shear strain and orientation, and then end. If the option say no, it will come out gamma max absolute equal to epsilon y plus epsilon x, and then will come out and display absolute maximum like just two option just now. Shear strain, normal strain, strength form strain, principal strain, and orientation. Maximum in plane shear strain and orientation. And then we'll end the lastly we'll end the process. The process will terminate. That's all for flowchart.
Okay guys, now we're going to the code. So you see this, we enter the value of the theta A, theta B, and theta C, which is 0, 60, and negative 60. So we enter the value for EA is negative 250 in the micro, and EB is 300, and the EC is negative 200. So we see the final value is EX is negative 250. Same in the rubric, and the EY is 150, and the gamma XY is 577. It's the same. So we go to the second question is the in-plane principal strain. So I put the same AX and EY. This action is for the transformation, but this question doesn't have transformation. So we go to the next. So the principal strain is the E1 301. So we go here, it's the same, and the E2 is negative 401. We go to the angle is 27 clockwise. Is 27 clockwise. We got negative because it's clockwise. So the last question is for Y maximum in plane, which is 702, with this 702, and the rotation is 17.36. So for the third example is the maximum in plane shear stress. We include the value which is minus 360, and this minus 360, so 280. So we got the theta S. Theta S is the maximum in plane shear stress, which is 40.9. This is 40.86. This due to the bunda. So shear max in plane is 556. We got the 555.79. Next for the next for the principal strain in the last section. So we put the value which is 250, negative 150, and 120 in this area, and then we get the answer, which is average is the 50. Same, and the E1 258.81. The answer is 259. This is due to the round off, and the E2 is negative 158. So the theta is 8.35.